the radicals review. We'll start with the first set. In the first set, we're looking at simplifying the radicals, looking to see what groups can come out. And so we have -4 times the fourth root of 648, mn cubed. So we're going to take that 648, and we're going to see what factors 648 is created by. I always start if it's even, divided by 2. 324. Divide that by 2, we get 162. Divide that by 2, we end up with 81. We are no longer even, so I look for the next thing. 81 is divisible by 3, so 3, which leaves us 27, if I divide that by 3, gives me 9, which if I divide that by 3, gives me 3. Now I'm going to write out my factors. And I have a set of 1, 2, 3 2s. I have a set of 4 3s. There is 1 m, and there are 3 n's. So based upon my index, I'm looking for groups of 4. Well, I don't have any groups of 4 on my 2s. I do have a group of 4 on my 3s, and that's the only thing that can come out. So outside my radical is going to be at 3. And then I put my fourth root, and then I'm going to put what's left behind. So these were left behind, and so they 2 times 2 times 2 is an 8. N cubed, because nothing was brought out of anything else. We brought out that circle, and it comes out just as one item when it comes out of the radical. But that's not all. We had originally a -4 in front, so we have a -4 still there. So -4 times 3 is -12 times the fourth root of mn cubed, and that's your answer. Let's go on to question 2. Question 2, again, we are dealing with a radical. This time we're dealing with a group size of 2 because it's a square root. And 288 is the number. Again, we're going to start by dividing by 2, gives us 144. Divide that by 2, gives us 72. Divide that by 2, gives us 36. Divide that by 2, gives us 18. Divide that by 2, and we get 9. And divide that by 3, and get 3. So if I was to list out my numbers, I have 5 2s that were multiplied together. I have 2 3s. And then for my variables, I had a cubed, so that's 3 a's, and b squared. So I'm looking for sets of this time 2, because my group size is 2 when it's a square root. And so I have 2 sets of 2s, 1 set of 3, 1 set of a's, and 1 set of b's. There was no number in front, so for every one that came out, I write it down once. So 2 times 2 times 3 times a times b. And so each of those pink have come out, and that leaves us a square root of 2a. Now combine my combine my multiplication, and I end up with 12ab times the square root of 2a. And that's my answer. So let's go ahead and go down to the next one. This is again a square root. I'm going to take that 196. And divide that by 2. Gives me 98. I'm going to divide that as well by 2, gives us 7. Gives me 49. And divide that by 7 gives me 7. Now I'm going to write out my factors, and I have 2 2s, 2 7s, and then I have u to the 4th power, so that's 4 u's, and 4 v's. So looking for my sets, I have a set of 2's, a set of 7's, 2 sets of w, a set of v's, and another set of v's. Well, there was nothing that was left behind, so there's no longer a radical. Only what was brought out, so that's 14 u squared v squared, and that is my answer. On problem 4, we have negative 8 times the cube root of negative 16 times x to the 7th, y to the y squared. So first off, that negative can come out because it's a odd index, and it's just going to make the number in front positive. So I'm going to go ahead and rewrite this. 8 times the cube root of 16x to the 7th, y squared. And then I'm going to take that 16 and I'm going to identify the factors. 16 is even, so start with 2's. 8 is also even, divided by 2 gives us 4, which is divisible by 2, giving us 2. So writing out my factors in a list. And writing out my x's, I had 7 of them. And I have 2 y's. So I'm looking for, in this case, sets of 3. So I have a set of 3 2's. I have 2 sets of 3 x's. And I have no sets of y's. So that 8 just gets brought down. I brought out a set of 2. I brought out 2 sets of x's. And then everything else was left behind. It was a cube root, so I make sure I write the cube. And then I have 2xy squared under the radical. Combine my multiplication, and I get 16x squared times the cube root of 2xy squared. So let me go back to that for a second for y'all. And that is the answer. Number 5. On number 5, we have the 5th root. So that means that we're looking for groups of 5. And this time we're doing 64 is the number we're looking for the factors of. So 64 is even, divisible by 2, gives us 32. And if you use your resources as we go through these, you may have other problems where you've already factored out some of the items. And it's okay to go back and refer to those. 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. And so that gives me 6 2's that makes up 64. And I had 8 A's. And 5 B's. And we are looking for sets of 5 this time because my index is 5. And so I have a set of 5 2's. I have a set of 5 A's and a set of 5 B's. So when I have nothing on the outside, there's nothing to multiply out there, I bring out the 2AB, and then I have still a fifth root radical. I have a 2 left behind and 3 of the A's, and that is my answer. Number 6. We're dealing with 128. And so when we have 128, we want to make sure that simplify the radical as much as possible. And so we have, first we're going to see what numbers will divide into 128 evenly. Well, 2, which leaves us 64. Well, we just did 64, and we knew 64 was made up of 6 2's. And so when I do this, I can either go ahead and go to that knowledge or go ahead and divide out each time. And so if I list out my 2's this time, I have 7 2's. And I have X, 1 of those, and I have 3 Y's. So in this time, I'm looking for sets of 4. So there's a set of 4 2's. So only thing that came out this time is a 2. Everything else is going to stay under the radical, and the radical is the 4th root. And so that's going to be 2 times 2 times 2 is 8, xy cubed. Number 7. So in this case, I have 5 in front, so that means that 5 is going to get multiplied to whatever answer I end up with. And I have 27 that I'm going to look for the factors of. 27's, we've already worked with some. If you want, you can go back to your information on that, you can, or go ahead and divide it out. 27 divided by 3 is 9. 9 divided by 3 is 3. So I have 3 3's to work with. I have 4 x's, because it's x to the 4th power, and I have 3 y's. And so that 5 is going to hang out in front, and then it will be joined by any groups that we bring out. So we're looking for, it's a squared, so I'm looking for sets of 2. I have a set of 2 3's. And I have x squared, because I have 2 sets of 2 x's and a y. And then we have our radical that was left behind, which is a square root of a 3y. And so combining it to what we need, we have 15 x squared y times the square root of 3y. So in this next one, we have 144. And we have 7 times the square root of 144, m cubed, n squared. And so again, this is a square root, so we're looking for sets of 2 and seeing what we can bring out. Some of you may know the square root of 144 already, and if you do, go ahead and use that information. And so those of us that don't, we're going to go ahead and take 144 divided by 2. Gives us 72. Divide that by 2. Gives us 36. Divide that by 2. Gives us 18. Divide that by 2. Gives us 9. 9 divided by 3 gives us 3. And so if I was to look at my numbers, I have 4 2's that I multiplied together. I have 2 3's. It was m cubed, so that means I have 2 m's, or 3 m's, and 2 n's. So I'm looking for sets of 2. I said two sets of 2's, 1 set of 3's, 1 set of m's, 1 set of n's. That 7 just gets brought down times what we brought out. We have a 2 times a 2 times m times n. And then we're left behind, under our radical, is a square root of m. So let's combine like terms. 7 times 2 times 2 is, times 3. I've left off one of my factors. So we multiply all that together, it's going to be 84. M n times the square root of m. Now we're switching gears. We're going to be working with graphing. And when you sketch the graph, some of the key points I am looking for identifying and the things I'll be looking for each time is your vertex, your domain, your range, and then your graph. And so some of the things that help, so I've listed over here on the side. We're going to do X and Y change. And the X change is always going to be the 1, 3, 5. The Y change is your A. In this case, our A is 1. So now let's identify our vertex. It's opposite of underneath the square root, so that's going to be a -6. It's the same for the outside, so -1. So at -6, -1, I put a dot. That is where my square root function is going to start. Now, when I graph this, I'm going to go ahead and move with my changes that I looked at the bottom. So I'm going to go right 1, up 1, right 3, up 1. And it's always going to be a 1 if my A is 1. Right 5, up 1. And then I sketch in the graph, making sure to include an arrow on the right-hand side. Now let's identify our domain and range. Our domain are your X values. X values are always listed with the farthest left, comma, the farthest right. Well, the farthest left is my vertex, so that's going to be the same value as my vertex is. My farthest right is the arrow, so it's infinity. Where the infinity is always going to be a parenthesis. Where the number is always going to be a square bracket on square roots. Now let's go ahead and do our range. Range is going to be lowest, highest. And so my lowest value is going to be -1. My highest is going to keep going up. There's an arrow there, so that's going to be positive infinity. These, for domain and range, are always going to have one infinity and one number. Let's look at the next graph. This next graph is y equals a negative square root of x plus 5. So let's identify our vertex. There is nothing under the square root besides the x. So it's 0, comma, and then it's going to be the same sign for the number outside. So 0, comma, positive 5. Now, come over and graph 0, 5 is right here. Now let's graph our change. So the 1, 3, 5 is the same. There was no, this time we have a reflection of a negative in front of the x. So that means I am reflected over the y, reflected down. And so that means this is always going to be -1. So I go down 1, right 1. Down 1, right 3. Down 1, right 5. And I sketch in the graph, starting at my vertex and ending with an arrow going out. Now let's identify our domain and range. Domain, farthest left is 0, comma, farthest right is infinity. Range, lowest, well, that's where my arrow is. That's going to be the negative infinity, comma, my highest, which is 5. Give you a second to look that down. Let's look at the next question, number 11. We have the square root of x plus 6, and we have plus 2. And so let's find our vertex. Vertex is at opposite inside, so that's going to be a -6, comma, same outside, positive 2. Our domain are our x values. This covers, and so we'll look and see which way we're going. And so in this case, it's positive on both inside and outside. And so that means we're going to go with the changes just like it's listed below. Go right 1, up 1. Right 3 up 1. Right 5 up 1. And then I run out of room the next one will be over 7, but I'm out of room for that. And so I sketch the graph, making sure to include my arrow and my dot. So our domain, we start off, our farthest to the left is -6. Our farthest to the right is the arrow, so positive infinity. Now let's do our range. The lowest value we have is the dot, which is at +2. The highest we go is with the arrow, so that's the infinity. Number 12. This is the one where we changed up the answer and we worked with the fact this is no longer a 2 here. We're going to call that a 1. So our negative is the same thing as that 1. And so let's do our vertex first. The -6, or the 6 is inside, so that's going to go as the x value. There is no number outside, so that's a 0. So my vertex is at -6, 0. Now we're going to look at our changes. It's negative, so that means I reflected it down. And so all my y values are going to come down instead of up. And so let's go ahead and graph. We go over 1, down 1. Over 3, down 1. Over 5, down 1. Now domain are your x values. The farthest to the left is -6. The farthest to the right is positive infinity. Range are your y values. The lowest value, well in this case the lowest value is at my arrow, so it's going to be a negative infinity. The highest value is the 0. The next one, we have -1 plus the square root of x minus 3. This throws some people off the way it's written, so rewrite it. And as long as there's not a multiplication sign there, you can rewrite it according to the terms, the signs. So since it was plus in front of the square root, it's a positive. The 1 is negative, so it's a minus. So now let's identify our vertex. Our vertex is at +3, -1. The domain, we'll see what happens with that, the domain and range here in a second. Let's go ahead and graph it. And so we're at +3, -1. Put my dot. And then I am going to move with my changes. And so I go right 1, up 1. Right 3, up 1. And that's as far as I can go. Connect my dots. Put an arrow at the end. Now let's identify our domain and range. Domain, the farthest to the left, is going to be that +3. Farthest to the right is the infinity. Range, the lowest down, is -1. The highest up is where that arrow is, so positive infinity. So let me give you a second to look at that down. Let's look at this next one. This next one has a negative under the radical. So that means that instead of going right, I'll be going left. My vertex, because it's already factored out, is going to be opposite inside, same outside. If it wasn't factored out, that would be a step I would have to do. On this test, you will have it factored out. So at +4, -3. And then I go left 1, up 1. Left 3, up 1. Left 5 up 1. Then I run out of graph. Go through your dots, connect the line, draw in the arrow. The arrow is going to be over on this side. And so this time, our domain is going to look a little bit different. Our domain, the farthest to the left, is where the arrow is, so negative infinity. Farthest to the right is where the dot is at the vertex, so positive 4. Range, lowest down is going to be that negative 3. Highest up is at the point where the arrow is, so positive infinity. That is the last of the graphing ones. The next step is going to be when we're working with solving equations. On the test, I am not going to give you any with no solution. You are going to have to come up with a problem where there is no solution. So, looking at the first problem, we need to figure out how we're going to solve this. So, you have to identify which of the two methods are going to work. Is this a radical equals a radical, or is there only one radical in the problem? Because if there's only one radical in the problem, the first step is going to be to take and isolate that radical. So this is a radical equals a radical. So step 1 is going to be to square both sides. When we square both sides, we end up with a plus 8 is equal to 1 minus 6a. Next, we want to get our variables on the same side. I like my variables to positive, so I'm going to move it to where that's the case. So I'm adding 6a to both sides. Cancels out the one on the right-hand side, leaving me a plus 6a is 7a. The 8 I didn't change, nor did I change the 1. Now I need to move the 8 over to the right to be with the 1. And so this time I need to subtract because the 8 is positive, giving me 7a is equal to negative 7. Now I need to separate the 7 away from the a, and it's being multiplied, so I need to divide. And so a is equal to negative 1. That is my answer. If I was to go back and evaluate negative 1n, I will not end up with negatives under either square root, and they come out with the same number on each side. So that tells me this one does check out. On 16, we only have one radical. So that means step 1 is to get that radical by itself. So I need to add 9 to both sides. Very similar to when we were solving those square root equations, you have to have that, or absolute value equations, you have to have the absolute value isolated before you can work. Same thing here, you have to have that square root isolated before we can work. Now we're at the point where I can square both sides because we have the radical by itself. We square to get rid of it. Gives us 16 is equal to the inside because we have taken care of the square root by squaring both sides. Now we have to add 7. And so that gives us that 23 is equal to n. So that's your answer. Let's look at the next problem. Add 1 to both sides. Because we have to get the radical by itself. Even as the square root of 4v plus 1 is equal to 5. I need to square both sides. On the right-hand side, that's going to cancel out the square root, giving me 4v plus 1 is equal to 25. Now I need to solve for v. Subtract 1 gives me 24 is equal to 4v. Now I need to separate the 4 away from the v by dividing. And so 6 is equal to v. 18, we have one radical again, so that means we need to get it by itself. So that means I need to move the 4 away by adding 4 to both sides, as it was negative. It cancels out over here, leaving me the square root of 5p plus 25 is equal to 5. Now I need to square both sides. So that's going to cancel out the radical on the left-hand side, leave me just the meat of it, and 5 times 5 is 25. And I'm now going to subtract the 25 from both sides. And that gives me 5p is equal to 0. Some of you may not need to show this next step because you may go, oh, anything times something and I get a 0, that means that p has to be 0. That's fine. Or 0 divided by 5 is 0. So my answer, p equals 0. 19. There's a square root on both sides. So that means that I start with squaring my radical to cancel out my radical. 7b plus 1 is equal to b plus 7. Now combine my like terms, get my like terms on the same side. I'm moving my b over to the left, leaving me with 6b plus 1 is equal to 7. And if things like b's cause you problems because they look too close to your 6's, change this to x's. It's the same process. I now need to move the 1 over to join with a 7. So that gives me 6b is equal to positive 6. Divide both sides by 6. And b is equal to 1. That's your answer. And again, I'm not showing this process to go back and check it, but each time you should go back and double check and make sure there's no negatives under your square roots. Number 20. There's a radical on each side, so start off by squaring both sides. So 2a plus 1 is equal to 3a. Now I need to get my variables on the same side. I'm going to move it to where the variable is positive. If at all possible, I always go to where my variable is positive. Cancels out on the left, leaving me a 1. And on the right, 3 minus 2 is 1a. So 1 is equal to a. Again, we have a square root equals square root. So I get to start with a step of squaring. And so I end up with 21 minus x is equal to x divided by 2. Well, I don't like to work with fractions, so if I can ever avoid it, I will always try to cancel out my fraction as the first thing. So I am going to multiply by 2 on both sides. And on the left-hand side, that means I need to distribute it to each part. So 42 minus 2x is equal to x over 2 times 2 over 1, which is just x. Now I get my variables to the same side. I'm choosing to move my negative 2x over to the right-hand side, giving me a positive 3x over there, canceling it out on the left. Give me 42 is equal to 3x. Now I need to divide both sides by 3. And that gives me 14 is equal to x, which is my answer. This next one doesn't have a radical on both sides, but there is still only one radical. So what that means is I need to take and cancel out that radical by squaring both sides. So I'm going to square both sides to cancel out that radical. So that gives me 8 minus 7b is equal to 64. Now I need my variables on the same side and my constants in the other. Well, there's only one variable, so I don't have to move it. But I do need to move my 8 to join the 64. And so that gives me negative 7b is equal to a positive 56. To separate the negative 7 from the v, I need to divide by negative 7. So v is equal to negative 8. And again, checking it back up in the original problem shows me that that's not going to give me a negative under my radical.